relative max or min at these values. So that's the justification for making the assumption as to why we picked those points. Good? Easy? We're good on it? Yes? Don't look for the answers online, okay? Alright. We're okay? That was a recap of what we did yesterday, just taking it a little bit to the next level and actually understanding what it means, okay? The next part is something new. I don't know if I mentioned it yesterday. The normal line. Anybody remember me saying that yesterday? No? Okay. Anybody remember talking about perpendicular lines in Algebra 1 and Algebra 2 and geometry? Yes? What were two lines that are perpendicular? Two lines that intersect but form what kind of angles? 90-degree angles or right angles, yes? Okay. Now, was there anything special about the slopes of perpendicular lines and the line that they were perpendicular to?
They were opposite.
They were opposite reciprocal. So what does that mean? Opposite, what is that telling you?
Different signs.
Different signs, like my last name. Okay? And reciprocal in English, what does that mean?
Upside down.
To flip the fraction, right? Okay, cool. So, in calculus, all right, we have a tangent line, right? And then if you get the line that's perpendicular to the tangent line at that same point, the point of tangency, then that line that's perpendicular has a special name and it's called the normal line. Special name, but it's called normal. It's kind of weird, right? But anyways, so the normal line, all it is the line that's perpendicular to the tangent line at the point of tangency. Yes? Maybe?
Yeah.
Alright, so let's practice this, okay? So pictured to the right is the graph of this function. Let's draw the tangent line at 1 and then estimate the derivative at 1. Okay, so let's draw the point first. So what's the point? 1 what?
2.
So my point of tangency should be 1 comma 2, yes? I gotta draw a tangent line, Daniela. Okay? So let's draw the tangent line. But after I draw it, this is telling me to find the what? Okay, the derivative, which means what? The slope of the tangent line that I draw, right? So I'm going to draw it kind of like we were doing it yesterday, and I think it would be a good place right here to put it. So that would give me a slope of what? Negative 2, right? Because I would go 2 down, right? And 1 to the side. Okay, so I drew the tangent line, and now I'm going to estimate this value. So what would f prime of 1 approximately be? What do we say? Negative 2. This is the tan line, right? Okay, can we write the equation of that tan line? We should be able to. We've done this so many times. What's the point of tangency?
1, 2.
What's the slope that we figured out?
Negative 2.
Negative 2. So what's my equation? Equals times x minus 1. Are we okay? Super easy? Alright, so the next statement is basically saying what I told you earlier. The normal line is a line that is what? Perpendicular to the what? At the point of tangency. So then it says draw this line and find the equation of the normal line. So now I know I need to draw a perpendicular line to this one, but how do I know exactly where to draw it so that it has an angle of 90 degrees? Do I just más o menos it, or do I actually figure out how it's supposed to be? I gotta figure out the slope so I can draw it better, right? So how would I figure out the slope for this guy? Very good. So what would be the slope of the normal line?
No, 1 over 2.
Positive 1 over 2? How did we get that? to get this, we had to find the opposite reciprocal, right, of the slope of the tangent line. So once I found the opposite reciprocal of the slope of the tangent line, I knew the slope of the normal line. That one has to be perpendicular. Good? So let's say the slope of the tangent line, let's say m tangent equals 3 over 4. What would be the slope of the normal line?
Negative 4/3.
Negative 4 over 3. These two would be perpendicular to each other. You understand? Good? Alright, so let's draw it correctly now. So from this point of tangency, I'm going to go what? 1 up and 2 to the side. And now I can draw my perpendicular line to the tangent, which has a special name called the normal line. Don't freak out on a test if they say find the normal line, find the slope of the normal line, find the equation of the normal line. Okay? Now can I find the equation of this normal line? What do I need to know? I need to know the point. Do I know it? Yes, and I need to know the slope. Do I know it? Yeah. What's the point? Is it the same one as the point of tangency? Yes, because it has to be perpendicular at that point. And what is the slope of the normal line? 1/2. We're not going to put SOT there because we're not doing the what? We're not doing the slope of the tangent, we're doing the slope of the normal line. Okay, so what would be the equation of that red line up there? 1 minus 2 equals 1/2 times x minus. How do these two compare to each other? What's different?
The slope.
The only thing that's different is the slope. So if I figure out this line, can I figure out this line really quick from this one?
Yes.
Yes, okay. So on your assignment, sometimes they might ask you to find the equation of the normal line. So in order to do this, I have to do the equation of the what?
Tangent.
Of the tangent line. Or not necessarily the whole equation, but I have to figure out the what?
Point of
The
tangency
slope.
and the slope.
I need to figure out the slope of the tangent line and then perform the opposite reciprocal of it to be able to write the normal line. You understand? Pretty easy? You think you can do this? So when they say find the normal line or the equation of the normal line, what does that normal line represent? A line that is perpendicular to the tangent line at the point of tangency. Good? Yes? Alright, so for your assignment, what I want you to do is complete the rest of the handout. Right? It has some problems with the table where you're estimating the slope. It has some problems where you're finding the derivative using the definition of the derivative like we did on the quiz. And then it has some problems with equations of tan lines and normal lines. Okay, so work on the rest of it for homework. And if you have questions, you can ask them tomorrow. Good? Yes.
Mr. Spencer, you can figure out the school?
I will be here, but I have you